All right. So today we're going to be going through some 3-axis, and mostly I just want to show you guys a few tips and tricks, show you a few tool paths for just that are just very helpful for your 3-axis machining that you'll be able to do. So I drew up this part, and the way I got it set up right now, there's a lot of 2D on it if we want to treat it as 2D, but this whole bottom section, this whole inside in here, and then if I flip it over, the other side has something kind of similar to that. It's all tapered. So there's no real nice straight walls on this. I mean, outside there is, but this is all 3D. The thing is, there's times when I want to machine everything all at once, and there's other times that I want to break it apart and I want to separate as much as I possibly can. So when I rough something like this out, I'd prefer not to have it, or not when I rough. I want it to rough and cut these pockets in. But when I go to do this finish right here, this is just a sphere that got cut into the top of that shape. When I cut that, I'd rather that be one full clean surface that covers up these cutouts and everything. Now, if you had this set up properly and you weren't doing weird things like I was, Scott, can everyone else hear me? Can you guys? My microphone says I'm giving sound. Can someone just verify that the sound's working? All right, Larry's got it. Scott can't get it. Phone is good. Bill. Okay, so let me send so you guys are all good. Thanks. Let me just send a message to Scott real fast. How do I do that? Right there. Okay. Send chat message. This is to Scott. Try. All right, I've told him, hopefully, I don't know if you can hear me. If you don't get sound one of these times, if you ever join one of these and you don't get any sound or anything, one of the best things I've got everyone do is just, oh no, I'm losing audio quality. Unused internet applications. Timeout, 1 second, close this. All right, there we go. Closed out of my apps. All right, so if you ever do have sound issues and the meeting started and you could see me moving around on the screen, you can usually restart the meeting and it should rejoin. If it doesn't, we'll have to try and do something else. Sounds good in California, Kool-Aid-fornia. Okay, cool. All right, so here's the part. So we're gonna go in and make a cut on this, and it's a weirdly drawn part because if I go to a top view here, these pockets that go through, they're not straight through pockets. I had to go through, and I had some straight through pockets, but it looked real boring. I wanted to kind of spice it up a bit. So I went in and I modified a pocket to give it a taper, but a taper on only 3 sides or I guess 2 sides of that pocket. So this back wall is straight all the way down, but this front has a taper. In this top side, it's flaring out to the top. So you got an opening wider on the top than the bottom. But then when you flip it over, it's the same kind of thing. The flare goes to the top. So we should be able to machine everything from two different origins, one from the top, one from the bottom, and that should do the whole part. I don't suspect any other setups that we'll have, but I've been wrong before. So we'll find out when we get into it. So I'm going to go over to my CAM tree, and I'm going to right-click on my CAM defaults, and I'm going to start with a new job. I'm going to do milling. I'm going to use my BC3X mill, and for here, I'm going to go right into the stock wizard. So into the stock wizard. Now with the workpiece, whenever you're working with a workpiece, the only time you really need to pick a workpiece is if you have the finished final solid model on the screen. So in this case, I have what I want to come off the machine on the screen right now. So I'm going to go ahead and pick that geometry and then hit next. Now right here, we can go and start creating our stock. So it starts off with this rectangular piece. It's always going to go to rectangular. So I'm going to start with a cylindrical piece of stock. And what you'll see is the preview doesn't automatically update super quick like we have right here. So what you could do is you could say calculate stock and then just give it a second. This is a pretty intricate model. And now that it's calculated, it'll create that stock on there. And then, pretty much from there, I just want to scroll down and hit the forward option. And this is where we get to set up our origin. Now, this is where it gets tricky, especially with round parts. The way that I drew this part was this surface right here was originally my 0. And then I added this little step on. So what looks to be top dead center on this part right now it's not actually top dead center because we're not at the top of the part. We're off the surface that I created because the origin that BobCAD always defaults to is the XYZ 0 coordinate. It doesn't matter where your part is. That's where the origin's always going to default to from the start. So in this case, I want to pick this point up here. So in version 31, we just click the origin box here. We click on the point we want, and then we can go ahead and hit OK. But in this case, before I go ahead and hit OK, I want to shift this part up so that it's inside my simulation, so it's not inside my table. When we set up zeros between BobCAD, when we're setting up that origin point right there, we're defining 0. And when we build our virtual machines, the 0 on that virtual machine's dead center on the table with the spindle touching the table. So take the tools, holders out, and have the spindle touch the table dead center. That's kind of the virtual machine 0. So what I'm changing here with this work offset is I'm virtually just lifting my part in the Z. I'm going to do 4 inches. I think it's about 2 inches, 3 inches thick. I can't remember off the top of my head. So I'm going to go 4 inches, and that's just going to lift this part out of the table so that it's not sitting inside the table. If you ever launch your simulation and you hit play and you see your tools turn bright red as they're cutting, that means you're gouging something. But if your part's not turning red along with it, it usually means that you're cutting your machine. So if you have the machine view, if you were to turn that on, you'd be able to see that you're cutting inside the table of the machine. And it's nothing, changing this does nothing to the G code. It has nothing to do with really anything G code wise other than, nothing. It doesn't do anything to the G code. All this does is shift the part up inside the simulation. You could also use it for turning, or for mill turn more than anything. And it's a way to shift your stock out of a chuck, and you can use the X axis for something like that, or depending on what you're cutting, the Z axis might be it. But when we're done, we hit OK. And again, you won't see any changes at all, really, since we haven't run our simulation yet. We won't notice anything. That's just something that I know I'm going to have to change, so I might as well change it now. Clearance planes at 1 inch. I am okay with 1 inch. I'm not going between vices on this job, so I really don't care if it, as long as it can clear the top of the part. The clearance plane in this case, it's only going to come into play really the beginning and on tool changes. At the beginning, the end, and on tool changes. Other than that, everything else we should do when we're going from one hole to the other, it should be using the rapid plane. When we feed from one side to the other, should be using the rapid plane. We shouldn't be using the clearance plane all the time. But we do want to make sure that clearance plane is the highest point on our machine. This should be high enough to clear anything on the machine. And if it's not, change it so it is. And then hit OK. All right, so now if I go ahead, I can blank out my stock. And by the way, I just wanted to bring this up because I had a few guys ask me this over the past couple weeks of the color of the stock. How do you make it show up, and what color does it show up as? Now, I don't think you can change the default color, but you can right-click on the word stock here and change the color. The bigger thing, though, is I don't need to look at the stock all the time. My main thing is blanking it out. But after talking to some customers recently, they don't like to blank it out, but they want to make it almost invisible. They want it to always be there, but nearly invisible. So the easiest way to do it is to go down to transparency. If you bring your transparency to the right, it'll make it a higher transparency. So it makes it more easily see-throughable, I guess is the easy. It becomes invisible if you go all the way to the right. It blanks it out completely. And if you do that and you set the default as that, you'll never see stock. So I don't recommend going all the way to the right, but maybe a couple notches from the right, maybe 1 or 2 notches from the right is a pretty good spot to be. And then you could say set my default. Now when I hit OK, we can see I have just this very faint outline of stock on the screen. And opacity, yeah, that's what it is. Opacity, opaque. It's opaque. Yeah, that's the word I'm looking for. Transparent, opaque, whatever. We need to make it so we can see through it and see our part. That's all we're going for. Thanks, Brian. Let me just set this back where I had it because I got mine at the level I like it. I go 2 notches all the way from the right back to the left, 2 notches to the left. But mine's usually blanked out anyway, so I usually right-click on here and blank it out immediately afterwards anyway. So there we go. So now that the stock has been created, we can actually start getting into the tool pathing. Now this one's kind of weird because there's a few different ways I can tool path this. I can rough it and not cut the pockets, or I can rough it and cut the pockets. That's the main 2 ways. I'm going to rough it and have it cut the pockets, but I want to show you something afterwards. One of the big things that we really try and teach is the whole dynamic machining strategies, being able to go into one feature and do all of your tool pathing from that one feature. The problem is that's not always realistic. That's not the way that you're going to be able to machine every part that you want to do. And so when we go in here, if I right click and I go down to my mill 3-axis, the first toolpath I'm going to create is going to be just my roughing toolpath. I'm not going to put any finishing passes on it at all, because my finishing passes are actually going to use a different piece of geometry. So first off, select geometry. I'm going to just drag a box over the whole part and then right click and hit OK and then hit next. Now, top of features, 50,000, that's what I got set for that top. That's actually, I think, that little lip there. So I may not have gotten my origin in the right place. Next, okay, we get to the machining strategy. So on the machining strategy page, I'm going to be focusing a lot on these pro toolpaths. So if you do not have the pro toolpaths and you're doing 3-axis work, get them. They save you a lot of time. They save you a lot of struggles. Not that I don't care if you guys get them either way, but it will help you with the headaches and the fight that you have that goes on with BobCAD and really any CAM system. When you're struggling to put a toolpath on a part, you're going to struggle to put a toolpath on a part regardless of what software you're using. But the pro toolpaths just do things for me. Yes, Randy just said they're well worth the money. They definitely are. I will say, if you're not doing a lot of 3-axis, start with the standards. But if you start getting some jobs and it would benefit you to be able to have some more control over some of these toolpaths, definitely look into the pro toolpaths. They're just some of the better ones. Now, not saying you can't get most of this stuff done, not that you can't get almost all your parts done with the standard toolpaths. The difference between the standard and the pro is, well, there's huge differences, but really for me, it comes down to how hard I feel like working. If I use the standard toolpaths, there's a very good chance I have to work and think a lot more. And with the pros, it does a lot of the work for me. So I have some default kind of numbers that I use. And as I use these default numbers, it works for a lot of these parts. So I have some settings that I primarily use already. And then I just tweak those settings as needed for the part. So in this case, I'm only running the rough pass. I'm not going to go in and add my finish passes in right now, because like I said, the finish passes are going to use a different piece of geometry that we have not created yet. Yeah, Brian just said it. Work smarter, not harder. Use the pro versions. It's true. It really is. I'll do a webinar here at some point where I'll do a comparison between the two. I'll do the same part from standard and one with pro. I did it a couple years back, and it seemed to be a pretty good hit. Just to let people see exactly kind of the differences between the two. So I've gone in, I've set up the advanced rough, and then on this page, all I did was turn on the arc fit option, and that's just so I get arcs inside my G-code program. Next, we have the roughing. So I'm going to use a 1/2-inch flat end mill. So I'm just going to zero out the corner radius there. If you went in and set up a tool crib beforehand, that's definitely the smarter way of doing these things. Just because you have more control over exactly what tools get picked. And BobCAD doesn't pick the random tool. It'll always try and pick a tool that from the category that you picked it from. So it's not going to default to a 1/2-inch flat end mill if I don't have a 1/2-inch flat end mill in my library. If I had a 3/8 flat, it would actually give me the 3/8 over this 1/2-inch, just because it's one that I have in my crib over my library. So, and just so you guys know it, if you haven't seen it yet, to know whether or not you've picked a tool or whether BobCAD picked the tool, take this bar. So you go up to the tool crib, you go to this bar right here and bring it all the way to the right. And you'll see right here, it'll either say auto or picked from library. Picked from library means you picked it. Auto means BobCAD picked it. And yeah, that's pretty much it. If you replace a tool, so if I get rid of this 1/2-inch end mill and I put in my own tool that I pick up, that 1/2-inch end mill will disappear from the system because it's an automatically picked tool that after it's no longer needed, well, that's exactly it. It's no longer needed. So it can get rid of it. So I'm going to use it still. Feeds and speeds are over here. They are based on the tool material, the surface footage. Well, all that surface footage and plunge feed per tooth and all that, that's getting pulled from the material under the stock over here. And we can't see it right now because it's not expanded. Probably looking at this, it's probably still 1018 carbon, just because we're at 6 inches a minute with a high-speed steel tool. So probably 1018 carbon. I haven't changed it yet or ever. It should be the default. So next. All right, the patterns. We got a lot of patterns with this advanced rough, and we went through a bunch of them last week. So for those of you that didn't see it last week, I'll upload the video. One of you guys asked me, Cameron or someone asked me about it earlier. Yeah, we will be uploading it. I'm trying to get them to upload it as soon as I have it done. They uploaded the one from 2 weeks ago. So who knows? Maybe this week they'll put last week's on. But I'm going to try and get them on hopefully the day after is what I'm going to be shooting for. The big problem with these webinars is they have to convert before they go up, and that takes a while. So I'll always work to get it on there. Hopefully by the end of the week. That's going to be my new thing, at least by Friday for you guys for the weekend. All right, so I'm going to do an offset out. Start from the inside of the pocket and work my way out, and then I'll hit next. Now, with the advanced rough, I do want to just mention, you can really use as big of a tool as you want with this kind of tool path. There is no boundary, so there's nothing containing the tool to a specific area. So if I wanted to come in with a 1.5 inch tool, I could. The only downfall to that is, well, I don't really have any corners that can be cut with a really large tool. So having a 1/2 inch end mill is a pretty good place to be. Now, depth of cut. We have so many different ways, and there's different thought processes on how much material we should take off. It really depends on the actual material we're cutting. But this tool path can do it for those of you that like to be a little bit more reckless. I don't want to say reckless, but let's say I don't know. You want things to run faster. You want to do things quicker. This tool path has the adaptive options. It has the high speed machining capabilities. So you can go in, you can give it those quick runs. You can do it with a much heavier depth of cut and a much shallower, much finer step over as you'd normally do. With the offset pocket out, I usually treat it more like a traditional job. So I'll set up a decent depth of cut, a decent step over, but I'm not going too aggressive in any which direction. So in my case, I'm going to go 50% of the tool. 1/4 inch depth, 1/4 inch step over. The only problem with leaving geometry like this with these big steps is, well, the finish tool needs to come in and clean up these big old honking steps now. So I would rather have it come in and now cut those big steps that are left into a few more steps. And that's what the number of intermediate steps is for. So if I say do one more intermediate step, where on this part we'd normally be left with a big old step down the wall, it's not going to cut that step into 2 smaller steps, but it's going to do it after it finishes roughing everything else. So we're going to rough everything out and then come back and slice these steps. And I just put a 1 in here just to have a number. You could do 10 if you wanted to, and that's just going to break that one large step into 10 smaller even steps. So you can do as many as you want, really. Right here's the machining tolerance. That's just quality of the tool path. That's pretty much if the tool path is running in a straight line, that tool's allowed to deviate a 1/2 thou in either direction. It's our tolerance that we build in. If you change it from 5 to 1, it will take longer to calculate, but the tool path will be better. So there we go. I'm going to leave it there. Right here, allowance. I'm just going to leave 30 thousandths. That's my go-to number to leave. And if it's not good enough or if it's too much, I can always change it. But I say for every one of you guys, you should have some sort of kind of default numbers that you use on a lot of these jobs. Your default step over, kind of your favorite tools should always be in your head, because there's a good chance you might be able to use them. And if you can't use them, well, you're in the same boat you're at now where you're trying to figure out what it is. But if you have a general idea of, I want to leave 30 thousandths. I don't care what part it is. I leave 30 thousandths. And if I realize that's too much, too little, I can always modify that. But I went into it knowing I had a number, and that does make it a lot easier. So next, right here, we have our leads. I'm just going to plunge in, but just a little talk about these. You got your ramp leads. You got 4 different types of lead ins or the automatic. So pick whichever one fits your needs. If you do uncheck the option for center cutting tool, it's not going to plunge down on the part. It's going to try and plunge off the part. So just a heads up. Right, here's our options. Now, rest roughing, I'm not going to do. You'd never rest rough your first advanced rough. Now, rest roughing would be used on the second or third or fourth, however many advanced roughs you have, but it wouldn't be used on the first because the first is the rough. The second one is going to be the one that looks at what's been cut and now only gives us a cut where the previous tool couldn't fit. So in this case, my first advanced rough, I'd ignore the rest roughing. I can turn on the machine flatlands, but I still have 30 thousandths of material showing up. So really the only time the machine flatlands is going to be beneficial to me, or it really is always beneficial. But what ends up happening is right here. So if this is what we'll call, top of part, this is a 50 thou drop from here down to this floor. I'm doing a 1/4 inch depth of cut. So my first pass is going to be way down here before it's not even going to see this area. It's going to be way down here. So machine flatlands would recognize that there's this area that's in between our depth of cut. It doesn't happen to hit perfectly on our depth of cut. And so it's not going to cut that normally. But if we say machine flatlands, we could tell it the minimum width of flatlands, and then we could also give it a maximum width if we wanted to. But the minimum width is going to tell it where to cut or to go back and recut these areas. It's still going to leave 30 thousandths on top, but they are going to come out a little bit better. So I'll do machine flatlands and then hit next. All right, here we got the links. We got within groups and between groups, just how do we connect that tool from one pass to the other. I'm not spending too much time. If you guys have any questions on any of this stuff, because I am going to bypass some of this. If you guys have any specifics, just throw it in the questions for me. Otherwise, I'm just going to keep going through this. We talked about a bunch of this stuff last week. So, yeah, if you do have a question, just pop it up in there. I'll answer it. Gouge checking. I get a lot of questions on gouge checking. When should you use it? When shouldn't you use it? And Troy knows how I feel about gouge checking. I am very cocky. I assume that everything I do is right until I'm proven wrong. That's just how I go. So I don't really set up a gouge check until I know there's a gouge. I just assume I'm always right because that's what my wife says. So I don't set up a gouge check, especially on the first one. I just leave it where it's at. If there is a gouge, I can see if a gouge check is the way to fix it. But you got to think a gouge can happen from so many things. It could be bad step overs, too large of step overs. It could be bad boundaries. It could be so many things that factor in. There's so many ways to take care of a gouge that sometimes gouge checking is the last one that I even go through. Not to say it's not one of the most useful functions when you do need it, because it is one of the best functions when you need it. But I'd say for the average 3-axis guy, probably not going to do too much gouge checking. Now, if you start getting into doing parts with a lot of fixtures and stuff, what's that? True grasshopper, but can also be used to tool right to a specific area. I don't know what you're saying, Brian, but can also be used to tool right to a specific area. So if that's what you're talking about, yeah, the gouge checking isn't what you'd use to get a tool to a specific area. It's more to get a tool to avoid a specific area. If you're watching your simulation and a tool's running into a wall that you don't want it to touch, you could set that wall up or that edge as your gouge check. But if you want a tool to cut, yeah, same kind of concept. Yeah, if you want a tool to really cut in a specific location, you'll want to set up a boundary. That's pretty much the easiest way to get a tool to cut right where you want. Set up a boundary, and then it will. So I'm not going to do anything special for the advanced feed rates or anything. I'm going to go ahead and hit compute. So just let that thing calculate. And while that's waiting, I'll get rid of those. Ooh, 21 of you showed up. Glad you're all here. Hope you enjoyed. If you have any complaints, that's too bad. I'm what you got this week. So no, I'm just kidding. All right, we'll let that thing calculate and let it go. Seriously, if you have any complaints, let me know. I'd like to change anything I need to make it more fun for you guys. After watching Al's, I didn't even watch Al's whole thing last week. I was editing some of it, and in the meantime, I was just watching. I think I watched 20 minutes of it, and it seemed like a lot more fun. So that's how I want to have this thing from now on. We're gonna have a lot more fun with this kind of stuff. So. All right, there's the tool path on there now. As fun as you could possibly make CAD-CAM software, right? Here we go. So I'm going to go ahead and blank this tool path out just so we can get kind of an idea of what's going on. So it's just going in, it's roughing, and right now I do have it cutting these pockets. If I didn't want it to cut these pockets, I'd have to create a piece of geometry that tells it not to cut those pockets. And that's exactly what we're about to create for the 3-axis finish pass. Now I'm okay with the rough pass doing what it's doing. So I'm going to leave that where it's at and shrink it up. And just rename it real fast. And I'm just going to call that rough. Caps lock got turned on. There we go. Rough. So now for the next one, I want to do a Z-level finish, because a Z-level finish is going to do a good work on these walls. They're not too steep, but it should have a decent finish. I can't use just one Z-level finish. I'm going to have to use a Z-level finish and probably a planer along with it. and that'll clean up the bottom and everything. So, but before we could do that though, for me to machine this kind of ledge here, I'd rather it just cut all the way around, just kind of do a circular toolpath that cuts the entire dome shape. So what I want to do is I want to construct the surface for that kind of dome shape. Now I've already made a layer for it. It's called the section view geo, and it's a function that I'd say is probably one of the most overlooked. Hold on, why is my machine set up way up there? All right, I'll fix that in a minute. But it's probably one of the most overlooked functions in the system. You go up to the Create 2D tab, and then right here you go to Section View. Now from here, I'm in a top view currently. I want to make sure I'm in a front view when I pull this. But what it does is if your part is centered, like I have it here, my part's perfectly centered on XYZ 0, I'm actually able to come in, and it just so happens with the way I set my part up, one of those edges, so one of these walls right here runs right down the XYZ 0. So this plane that it's creating, this section view plane, is splitting my part perfectly in half. And so what I'm able to do is I could come down here and say generate wireframe and then cancel out and then turn off my solid, and I'm left with this geometry. That's the geometry for, well, what I just pulled off from that section plane. So what we saw in that section plane was what we were able to pull off. The other way to do this, it's a lot more in depth, but you'd have to go into the Create 3D. You'd have to start by making a plane, and whether you use a planar surface or a rectangular plane, you'd have to make a plane that splits that part in half. So I'll just show you real fast. It's way easier. So here it is. I'll make a new, get the check mark up there. Make a new layer real fast. And this one's for intersection curves. You can use this on a scenario like I'm about to use it, or if you ever have trouble getting the spun profile to give you some turning geometry, cross-section a lot of times can do the same stuff, or cross-section, the section view or the intersection curves. So right here's my part. I'm going to go over to my UCS tab first and put a new plane right on the front. It's already created. I just needed to remake it or just turn it on. And now I'm going to go up to the planar. Now I'm not using planar. I'm clicking the drop down portion of the planar because under planar we also have our rectangular and circular planes. Probably the most, I don't use them ever, rectangular or circular planes. I usually end up drawing my part in the position I want. Let's go here. Oops, no, 6 inches should be fine. So I'll go ahead and hit OK. And so all I did there was create a plane that's standing in the front plane position, and then making sure that that plane is big enough to cover the entire part. Because now I can go over here, make sure my check mark's on that layer, go up to intersection curves, and I could say, here's my first surface. I want to find out where that surface there intersects this solid down here. Then I'll hit OK and cancel out. If we turn off the solid, we're left with the same geometry. So it's whichever way you want to go about it. You can use the cross section, or you can use the intersection curves. The problem with the intersection curves is you usually need to make extra geometry. I will say, though, I probably use intersection curves more than I use the section view option. I think I keep saying cross section. I mean section view, not cross section. The section view is it's just an option I never got used to. For the longest time, we had no way of, well, we had a section view, but there was no way to generate the wireframe from it. So for the longest time, the only way to pull geometry off was with intersection curves. It's a nice feature if you can create the plane in the right position. So there we go. Now I got this. So now with this piece of geometry, we actually have a lot more than I need right now. All I need is this arc here and this guy right here. So I need this full thing, because what I'm going to do is I'm going to take these lines that I have currently, and I'm going to revolve them into a solid model. And so when I revolve them into that solid, it's going to give me a new surface. So what I've done is I've selected the two I want to keep, and now I'm going to drag a box over the entire set of lines. And so that'll deselect what I had selected and then select what I didn't. And now I can just delete that stuff. So now I can go over here to my layers. And so I'm going to do one on this layer, one on the other layer. So right here, I'm going to turn on the section view for the top. So to create the revolve, I just go to the Create 3D tab and then go to Revolve. From here, it will default to 180 degrees. I've already done this with this part open. I was playing around with this a lot before you guys got here. So I've already changed mine to 360, but normally it'd be at 180. You would just change it to 360. and pick your geometry. So the geometry I want first is this line here. Now this is a single entity. There's really no right or wrong direction for this. So all I'm going to do is find my midpoint and then either go to the left or the right. Doesn't matter. Click it once, hold shift, click it again. There is the shape. We want to make sure we're going around the z-axis. So we're rotating around that z-axis. There's the arrow, the blue one right there. So we're taking and spinning around that. If we were to go around an x-axis, it would look like that. If we were going along the y, it would look like that. So we're going to go along the z and then just hit OK and cancel out. So now if I turn this on and I turn on my actual solid model here, we now have a cover for that entire area. So now there's no way for the tool to get inside those pockets again. So now when we go to our cam tree, we can right click on machine setup and then go down to the mill 3 axis. Select the geometry. I'm going to pick the whole thing again because whenever I do 3 axis, I pick the whole job every time. Hit OK. And now right here, we can go and select our boundary. So the boundary for this, I'm just going to pick the top edge of this. You'll see somewhere it's broken. It's just the 2 different surfaces I created. So just try and get to a point where you can get the full thing to light up. You'll see at certain spots, like right there, the whole thing lights up. So I'll go ahead and click it. That'll be my boundary. I want to contain that tool inside that area. So now I'll go ahead and hit OK. And then next. And next again. All right, so for the machining strategy on this one, I want to do a finish pass that's really good for the walls, which is going to be the advanced Z level. So I'm going to start with that one. But I know for a fact with this advanced toolpath or any of these Z-level toolpaths, they hate cutting flatter floors. You could even see it in this picture right here. As it gets to the top, this big gap is still going to be an area that doesn't get cut. So I want to make sure that I have the proper toolpaths in place. So I'm going to start with the advanced Z-level finish, and then I'm going to come in with the advanced planar after that. So we got the 2 of them. Now this, we turn on the arc fit to make sure we have our arcs inside of our G-code program. We go next again. This time we want to change up the tool. I'm all right with using a 1/2 inch, but it's going to be a ball mill because I'm finishing now. So 1/2 inch ball. I will need something for this corner out here. I set it to it's like a 25 thousandths fillet. I don't know why I picked such a small size. So realistically, I'd have to get some bullnose end mill or something that's got that radius to cut that in. But other than that, we should be able to use pretty standard tools on here. So next, right here, our patterns. So we get to tell it how we move the tool up from the top down or from the bottom up. So however we want to cut. I want to go from the top down, and I want it to zig. Now there is a spiral option here, but if you have access to the Pro Toolpaths, you have access to the best spiral you could ever put on a part, and it's the one that you can set up during the equidistant offset toolpath. Now the downfall to that equidistant offset is it's slow in more ways than one. It takes a long time to calculate. A lot of times it takes a long time to run, but the finish you can get out of it's brilliant. So use it as needed. I don't really like the spiral on this one unless I'm doing kind of more of like a helix hole. If I'm trying to get a hole made, I can use a spiral on that. But whenever you're doing anything with a Z level, you want the steepest wall you can get. 90 degrees, really down to about 30, 40 degrees, 30, 40 degrees being where it starts to do a bad job. So I'm going to go with a zig, just keep everything moving in the same direction. Depth of cut, like I said, I have numbers that I use for everything. These numbers will change for you guys when you're cutting your parts, but I recommend having some numbers where when you start thinking you're on your finishing, throw a 50 thou in there and compute it. It's going to compute faster than your probably normal finish of 10, 20 thousandths or whatever you normally do, but it'll give you an idea if you're even on the right track. I have no clue how many hours and how much time I've wasted putting a toolpath in and going, okay, this one's got to be a real fine finish, so I'll put it at 10 thousandths. I wait for it to compute, and then I watch the simulation and realize the toolpath I picked was not even close to the right toolpath. It wasn't even, my thought process wasn't even right. So what I do is I go back and start modifying. And sitting through all those calculations, you kind of figure out, hey, if I'm just trying to figure out which one's going to work, leave the depth of cut a little heavier, or leave it a little shallower, a little lighter. It'll calculate, or no, I guess heavier. Yeah, make it a heavier depth of cut. So I'll go 50 thousandths over 20 thousandths. Less toolpath, less time to calculate. The other trick to getting a toolpath to calculate a bit quicker is to change that machining tolerance. But you got to be careful with this one because it'll change not just the quality. Well, it changes everything. The speed of the toolpath, yeah, it'll calculate a lot faster. But the quality of the toolpath can drop as well. So I usually leave the tolerance, let that stay where it's at, do a decent depth of cut, enough that I can get an idea of how the finish is going to come out. And then when I'm ready to actually run it, I'll go change this to 10 thou, 20 thou, whatever I got to do. And I'll do this to all of my toolpaths that need changes, and I won't compute them until they're all ready to be computed. And then I can right click on the milling job up at the top there and say compute all toolpath. And then at that point in time, that's a good chance for me to get up, take a bathroom break, do what I got to do, but not have to sit here and stare at it while it's calculating. So I can get up and leave and let it do its thing. But by doing all of them at the same time, I don't have to do them, I don't have to do them one at a time. So simple perk. All right here we got our leads, just how we enter into the material. We got the plunge, the ramp, the spiral. With the plunge, you always get lead ins and lead outs on your finish passes. There's no cutter comp, but you do have leads for it. Options, boundary options. So I have a boundary. I want the center of the tool to stay on the boundary. So the center of the tool, if it hits the boundary, that's when it's going to stop. So you always got to remember there's another half of your tool sticking out on the other side of the boundary. That's partially the biggest, that's the biggest reason why I tell everyone when you're picking your 3-axis geometry to always pick the entire part. Because if all you pick is a surface and there's a wall on the other side of that surface, BobCAD's not looking at it. It's going to run right through it if it feels like it. So make sure you're always picking the entire model for your geometry. There will be times you can get away with picking just a surface, and a lot of people do. But for the most part, the best rule of thumb for when it comes to geometry selection for any of the 3-axis is just always pick the entire part. All right. 3D Extents is a nice one to turn on if it's an option. It's an option in most of the 3-axis Pro toolpaths. It allows the center of the tool to pass the edge of the part or the edge of the stock a little bit more to make sure it can cut the part. Still has to listen to the boundary if you have one set up. So be careful with that one. Right here's the good stuff. It's the angle range. So for this toolpath, and I'm telling you, but the toolpath does not like to cut flat floors. It doesn't like to cut anything really about, I'd say probably about 35, 40 degrees and below. Anything lower than that, and this Z-level toolpath doesn't even want to do it. So what I could do is I can say, let's do an angle range. Let's limit this toolpath to only cut the areas that it's good at cutting. So I could say start at, we'll go 30 degrees and end at 90 degrees. Then I'll hit next. So now I'm saying machine between those angles. So on the next one, I can get it to clean up what's not getting cleaned up right now. So links, not changing anything there. There's that gouge check again and the advanced feed rates. Right here, I'm going to go ahead and use the same tool. So I'm just going to jump up to the tool crib, pick my 1/2-inch ball mill, then hit OK. Next, right here, we have our patterns. Really not too much to this one. It's a planar toolpath. So it's just going to go back and forth, up and over, whatever it's got to cut. It's a very easy cleanup toolpath. And really, you could think of this toolpath, the way I think of it at least, this is the cleanup crew toolpath. It's the one that's going to come in and clean up a lot of the things that the other toolpaths might miss. This one should always be in your arsenal somewhere. Now, it's not the fastest toolpath to run, but it does a really good job when, for whatever reason you need. It can cut steep walls. It can cut flat floors. It can do any angles, really. The only time this toolpath has a problem is when it's got to cut along the same direction that it's moving in. So a wall, let's say a wall parallel to the direction you're cutting in. Because it's just like if you were walking along a cliff and you walked back and forth and slowly stepped over every time you got to the end of the cliff, you took one step closer to the edge, and then you walk back, and then you step closer to the edge. Eventually, you're going to fall off the cliff. Same thing happens with the planar toolpath, and you'll see those kind of results right over here in these areas. It's cutting. It's not going to be a good finish right here. So what we want to do is we'll have to either tighten up the step over to give it more to cut. We could go in and add an adaptive step over, which allows BobCAD to go in and add extra toolpath in the areas it recognizes are going to need it. Or you can go with a perpendicular step over. So it's going to do the entire part, everything that it can along one direction. So if we say the first one is to go along the Y, which is what we have, because right now we're set to 90 degrees. So 90 degrees is always along the Y. So it's going to go and cut everything that it can along the Y. And when it finishes that, it's then going to automatically go in and machine everything along the X that the Y was missing. So very awesome toolpath with this one. Great finish. The time on it you could adjust it. It's probably got more variable in it than, say, the equidistant. You could play with this one a bit more than the equidistant. But this is really meant to just cut everything that you throw at it. So I'm going to go with the standard. No allowance, no change in the leads. Not too interested right now. Options. I do want to do the 3D extents. Pretty much if I see that option, I turn it on. And then the angle range. I'm going to start it from 0. And we ended at 30, or I guess started at 30 on the Z level. The lowest we did on the Z level was 30. I don't want them to stop at the same point, because then we might leave an area that just doesn't get cut. So I usually like to give them a few degree overlap. In this case, a 5-degree overlap between 30 and 35, and then hit next. And then do my gouge check and all that stuff if I needed it. When I'm done, I can hit compute. And so we'll give it a second to calculate. This one shouldn't take too long. I don't think I set my step over up for my planer, though. So we'll see in a second. All right. So, yeah, like I said, I think I say it every week. If you guys have anything specific you want to see, I have a plan for the next few weeks or for the upcoming weeks. But if this is kind of the plan over the next little while, is just doing a bunch of part files, kind of working through them with you guys. So if you have part files you want to see done, let me know. As long as there's no sort of confidentiality agreement or anything like that, where we got 18 other people sitting in the room that are going to see your part. If you're all right with it, I'm 100% all right with it, as long as you send it to me beforehand, so I get some time to play around with it before, so I can kind of learn about it. But if you guys have any parts you want to see or anything specific, definitely let me know, because I want to do what you guys want to see. There we go. So all right, it's calculating now the planar toolpath, and like I said, I think I left the step over a bit hefty on this one. I definitely didn't go. I don't think I changed it to 50 thou. I may have, though. I'm not sure. So we'll give it a second to calculate. Yeah. How's everyone doing? If you want to leave a comment on how your day's going. How was Thanksgiving? Let's see that. How was your guys' Thanksgiving? I forgot we had that holiday last week. It was a beautiful, beautiful holiday. Mine was wonderful. I ate a lot of turkey. Way too much turkey. Fell asleep during a football game. It was a good time. Or not, guys. Beer. Thanks, Larry. You're the only one so far. Beer. I like it. I didn't have too much, believe it or not. It's I don't know why. 6-hour bird after brining for 2 days. That sounds pretty good. 6 hours smoked, guys. That's the way to do it. Smoke your bird. Also beer. I like it. No, I didn't do any. I didn't do much beer on Thursday. Kept it pretty good. Drank too much wine. I like your style, Brian. Wild turkey, Brian. That's the way to do it. Wild boar roast by Ron. Heck yeah, man. That's awesome. Drank too much wine. Tofurkey. That's the fake one, right? That's tofu stuff. Sorry, Jeff. If you're a vegetarian or anything. My wife does the whole thing. She's I don't know, pescatarian. I don't know what it is. She eats fish. Yeah, vegetarian. My wife does she eats a little fish here and there, but no meat. It's really annoying because I'm 100% meat eater. Not annoying. She gets it. I buy my own food pretty much. All right, guys, it was good talk. Here we go. The toolpath is done. Now, like I said, I didn't go too crazy with the depth of cut, step over. We didn't go anything, too deep into there. We got some toolpath. Here's the advanced Z level. So the finish on this at 50,000, I can already tell you it's not going to be really great, but the fix for that's just you give it a better finish pass anyway. You give it a better depth of cut or step over. So let's go ahead and check this thing out. The main thing I wanted to really teach you guys in this kind of session, and I don't know, it's been a long way to do it, but it's the part that you have may not be the part that you're going to be cutting. You could see I've had to add geometry in here to make it work the way that I wanted. So we're going to go in. We're going to start with our rough pass. I don't want to go too crazy fast. I think it's pretty glitchy for you guys watching it online anyway. The simulation seems real jumpy anyway. Can I send you an AR-15 to a session? I mean, we could do an AR-15 lower if you want. I would look around and see if Al's already done one, John. Because I want to say Al has probably done one of those by this point. If not, I'll talk to him and find out. If not, I have an AR lower somewhere. But if you have a specific, I would do it. Yeah, it is a really good part for indexing. And I have a customer. Is it you, Brian? Brian, do you cut AR lowers into like a 9mm version or anything like that? That's not you, is it, Brian? The name, man, I can't remember. Nope. Okay. Yeah, I have a customer of mine. He actually goes through, he set up an AR that he's doing a bunch of them. So hold on, time out just to do it. So right here, with these, so we can see that we have, it's interrupted cuts anyway. So I don't know if this is the way you'd want to actually machine this. My main focus here was just to show you, you can create a surface. You can go in and create a surface so that you can let your tool bypass these pockets. If you can block those surfaces, BobCAD can't cut them. So it makes it real easy to get a nice tool pass. So you may want to rough it out and leave that surface on there when you rough it. Who knows? You might want to put the pockets in. Well, you can't put the pockets in from the bottom side on this part because the walls are tapered. So no matter what, we have to go in and do a bit more machining on those walls. So for the machining on those walls, I'd probably just do another Z level with a smaller tool. I'd turn off that surface and let it run. But other than that looks pretty decent. Like I said, there's the finish pass, and it's going and cutting up here. I probably don't need it to cut up there. There's a trick that I use to get rid of that area, to take it away. And it's not using a boundary. It's using the height of the job. So if I come in here and I right click and say edit, I don't need that planer to cut the top. The Z level finish is doing that top portion for me, no problem. So if I come in here, I can say, let's go to the parameters page for the advanced planer here. And I could tell it a top of job. So right here, I could say, let's pick. And I like to pick this edge right here, even if it's not the right edge. That just tells me what I'm calling that location. So from that location, I'm going to go and say, I want the top of job to start at minus enough to get me past that tool pass. So if I say minus 0.25 and then just say finish. Now I'm not hitting compute, because if we hit compute, we got to sit through all of them to compute again. And I only need to recompute the one. So here's the advanced planer. If I right click on here now and just compute that one, it should get rid of all this stuff around that top edge there and leave me just the bottom here. But yeah, here it goes. I'm 2 mile shooter. What'd you mean there, Brian? You shoot a mile or you shoot 2 miles? I don't think you shoot 2 miles. I'm 2 mile shooter. Oh, yours is different. Okay, I gotcha. But yeah, John, if you want to send me I'll talk to, oh, yours is different. Yeah, that's fine. Send it over to me. Send it to, if you put the subject in, say for the webinar or for Mike D, put the D on the end. There's a few mics here. D is in dog. That's my name. If you send it to just support@bobcad.com and just say for Mike, they'll know who to get it to, and you could send it into me. So yeah, we could try it out. I don't know if it'll be next week. I'll have to play around with it. Those ARs are, well, they're not fun in any way, but yeah, we could definitely do one for sure. There's a lot that goes into them. So the biggest problem, and this is taking way longer to calculate than it should. So let me try this over. Try this again. So you shoot over a mile, Brian. Very cool. I don't. I don't even know where I could shoot over a mile here in Florida. We have a 1,000 yard. I think it's 1,000 yard range. It's down south from us. I haven't. The day I went down there, they didn't have the 1,000 yard open, so didn't get to shoot that day. There it is. Now you can see. So that's a good way of getting rid of kind of this area, this top section. If it's not needed, just change the top of the feature or the top of the the top of job, not the top of job, top of feature, top of job under the parameter. So you change the top of job to a negative value and let it cut from that value down. I didn't need anything above it, so there's no reason to have it there. Okay, I thought I was crashing. All right, so now if I turn off this this section view layer that I made, we're back to this kind of thing. So the last little cut I want to make, I'm just going to do these inside pockets here. I have some geometry set up for the pockets if I could find it. Where the heck did I put it? It's showing. Hold on one sec. Let me turn this one off. Okay, there's my pockets. So the only thing I'm worried about is if those pockets are big enough, and they are not. So I'm going to extract some edges on here. So I'm going to make a new layer. I'm going to call it bounds because this is going to be for a boundary on here. Give me 1 second. Let me just clear these things away. So again, yeah, just so you guys know, if you want to send me parts, it's just address it to me and then the website or the email, just support@bobcad.com. That'll get to me just so you guys have it. All right, what do we got going on here? All right, now, so what I do is I'd come in and on my bounds layer, I go to the Create 2D tab and say Extract Edges. What I'm going to do is I'm just going to pick this surface right here and this surface right here. There's a lot here, but I can go ahead and hit OK, and then I'll turn off these two, and now I can go in and get rid of really whatever I need to get rid of. So I'm going to go into my Utilities and then Quick Trim, and I'm going to start trimming away these things inside just like this, all the way around. I really didn't, oh no, I really didn't need it actually. I could have grabbed, no, I needed to grab both of them because I needed this whole surface. And this surface, when I picked it, gave me these lines back here. So I did need all of it. So that works. All right, cool. So that's all I need. I'm then going to delete all of this that I don't need. So this. Let's go fast. There we go. Delete. So there is the geometry. So basically, when you look at a boundary, when you're working with a boundary, when you look through your boundary, you should see the geometry that you want to cut on the other side. So if I turn on my solid, kind of turn it on and off, you can see this matches that corner just about perfect. You can actually see it right there. So there's the line, if you guys can see that on there. I'm trying to see. Yeah, there's the line on the inside there. And so I'm going to use that as the boundary. Doesn't matter if they're flat, doesn't matter if they're curved like they are here. If you were to flatten them out, same exact situation. It's as long as BobCAD sees through it. The best way I explain it is if you took your end mill and you put your eyeball on the tip of that end mill and looked straight down through your boundary, you should always see the geometry that you're trying to cut. Doesn't matter if the boundary is 150 inches above the part. As long as you look through that boundary, you see the geometry you want to cut, doesn't matter. It can be curved, can be 2D, does not matter. It could be a wireframe. You can even pick edges. So there's a lot of different ways to get boundaries here. One of my favorites is to make a layer and put them on the layer. And the reason I do this is because I don't want to have to repick the geometry off a surface every single time. So it makes it a lot easier for me. All right, right here, we're going to go in. Let's do the pocket. So I'm going to go in, mill 3-axis, select geometry. I'm going to turn my solid on. And again, just pick the whole part and then hit OK. And then for the boundary, I'm going to come in, turn that solid off, and then hold Shift on my keyboard and click each one of these all the way around. So I want to pick all 6 of them, just like that, and then I'll hit OK. So from here, I want to go in. I want to do another advanced Z-level finish. I shouldn't need anything after the Z-level finish because there's no floor to this one. So I just want it to machine down. But I'm not going to be able to use a 1/2-inch end mill on this. So I'm going to switch it up. I think I can get away. I think I set the radius to those corners at about 1/8 inch. So a 1/4 inch ball should be fine. We will find out here in a few minutes when it finishes calculating. So for this one, we're going to go from the top down. I'm going to do a depth of cut on this. We'll go 20 just so we get a bit nicer finish on it. Other than that, just work my way through 3D extents. No angle range on this one. And then no links, no changes for the links, no changes for the gouge check, no changes for the advanced feed rates. When you go through these toolpaths, it shouldn't take you but a couple minutes to get through each one. 2 minutes per one. You're not changing every setting. The reason you don't want to change every setting is you might not need to change every setting. So my whole thing is, if I don't need to change it, then I'm not gonna change it. So I'm gonna go in now, hit compute, and we'll give it a second. Yeah. Anyone else got some cool jobs coming up? We got John here. He's cutting some AR-15s. Anyone else got something cool they're cutting? Doesn't matter. Car wheels. There's so many cool things you could cut. If you do cut anything real cool, send us pictures. We always love seeing this kind of stuff. We don't have a machine to actively run, so we rely on you guys to get our fix of parts that we need to see. Google just doesn't do a good enough job. So send us whatever you guys. I mean, we'll take just about anything. Al's always looking for part files to machine in videos as well as everything else. I have no clue. Oh, that looks all right. I feel like I'm feeding a lot more than I want to be. There's a lot of rapids going on here, but it's partially because it's kind of an open section here. Let's turn this on, and it's only going in and machining the areas that really need it. So let's see if we can launch that simulation. And then I'll fast forward to this one. And yeah. All right. So now fast forward to this advanced Z-level finish. If you guys are interested in kind of how I drew this as well, if you are interested in more CAD over CAM, it's whatever you guys want to see. I'm more than willing. I want to teach you guys what you're interested in. So if it's more toolpath you want to learn about, we'll do more toolpath. If you guys want to learn a bit more about a little bit of the CAD or anything like that, just let me know. We can schedule for it. There's a lot of new stuff in the version 31. I think we've pretty well covered most of it. But there's definitely some things. Oh, come on, rotate. There we go. Definitely some things that if you don't know how to use them, they're way different than version 30. Larry Johnson, interested in some 3D CAD. Yeah, I could definitely do some 3D CAD. I enjoy drawing it. It is definitely not as easy as 2D for sure. Yeah, cool. Ron and Larry. All right, cool. I'll plan this part out, and I like I said, I don't know the whole schedule on. I mean, it's pretty much whatever we feel like doing when I do these webinars, but they like to have some sort of schedule for those of you guys that sign up. But no, I'll plan it out. We'll do a part. I'll draw a part like this or something where we'll do a bit of 3D modeling, because this one actually took a lot. I had to go in, I had to cut the sphere into the part. And then when I put the pockets in, initially I just made vertical straight pockets. That was easy, just an extrude cut. But then I wanted to change it up, make it a little bit more complicated. I regret that now that I'm seeing this toolpath finish this part, that I shouldn't have done that. But I'll tweak this. I'll get it all working, and I'll show you guys how it comes out when it's all done getting machined. But it's not cutting into anything. It's just there's a lot of excess material that I don't know why the Z level is not cutting this back wall. So I'll have to look into it, find out what's going on. But yeah, for sure we could do some 3D modeling, some more CAD. Like I said, if you guys have some part files that someone sent you and you want to try and figure out how to possibly reverse engineer a little bit of that stuff as well, we could look into something like that, because I can take apart, as long as I got enough notice, I can pretty much change anything or recreate anything. I won't say that. I'm not that good. If it's something that's real goofy inside of SolidWorks, the biggest thing for me is like fillets and stuff. BobCAD struggles with fillets. And so when you try and throw some goofy fillets on, I was trying to do a much bigger fillet in this corner here. I wanted a big fillet here, but I also wanted a big fillet here, and have them all kind of blend together around this part here. But I couldn't get the fillet to work out, and I eventually gave up on it. So, yeah. So send me a dish you were trying to design but could not make it solid, had filleting issues. Yeah, filleting issue. Filleting's the biggest problem I run into when it comes to drawing. I mean, the thought process on doing a 3D drawing anyway is always a little bit more difficult, because you do kind of have to have a plan going into it about what am I going to make first. With this one, I had to make pretty much the whole body and then cut the pockets from it. There's no other way of doing it but that. I mean, I guess there is other ways, but not the way I wanted to do that. I'll be using SolidWorks to draw this part. This part I drew inside BobCAD. I am not good at SolidWorks. I've been wanting to take the class for a very long time, but I just haven't had time. I traveled for such a long time, I never had a chance to take it. But all right, that's where I'm going to stop.